Okay, today's lesson is on the unit circle, and this is where we jump off into the abyss known as trigonometry. Several of you have already been experienced enough in sine, cosine, and tangent in right triangle trig, but this will be new. We're going to look at what's called the unit circle and take a unit circle approach to trigonometry when we first start out here. So our objectives today are to, number one, determine what the unit circle is, find terminal points on the unit circle, and then use the reference number. Okay, so here we go. What is a unit circle? Well, literally, a unit circle is a circle with a radius of 1 centered at the origin. So if you remember from first semester, our equation for circles was x minus h squared, quantity squared, plus y minus k, quantity squared, equaled r squared. And now we know that h and k are 0, 0. So x squared plus y squared equals 1 because our radius is 1. So that's what we call the unit circle. Well, why is this important? Well, the equation x squared plus y squared equals 1 can lend us a lot of ways to find different x's and y's. For instance, we want to show the point radical 3 over 3, radical 6 over 3 is a point on the circle. Well, to do that then, all we would have to do is put it in the formula. Does it equal 1 to be on the unit circle? Well, radical 3 squared is 3, 3 squared is 9. Radical 6 squared is 6, 3 squared is 9. Does 3 ninths plus 6 ninths equals 1? Sure, 9 ninths. So we've determined then that this point, P, is indeed on the unit circle. And it would be, if we just roughly drew one here, it'd be over, let's see, like right here and here, probably. Here's your x, here's your y, and this would be your point P. Okay, now just roughly, but you can see how that works. Remember, the radius is 1, how that works within the circle. Okay, now let's talk about terminal points on the unit circle. And this basically says if we mark off a distance starting at the origin, or I should say the initial point, which is going to be at 1, 0, okay? So this point right here is 1, 0. If we go counterclockwise, that is what we call a positive direction. So t is greater than 0. As you can see, t is greater than 0. But if we go the other direction, if we go clockwise, t is negative. It's less than 0. These points right here are called terminal points. It's where the direction, where the distance ends. That's where we end, where t ends, okay? So in this way, we arrive at a point P, X, Y on the unit circle, and that's called a terminal point. Now, the circumference of a circle is 2 pi. We've known that for years. Or of this circle is 2 pi, because 2 pi r is our equation. Well, the radius is 1, so it's 2 pi. So if we start at 1, 0 and move all the way around the circle counterclockwise, we went 2 pi distance. So if we go halfway, it's pi. If we go a quarter of the distance, it's pi over 2. And you can see that in these formulas. So then looking at what they would look like then, pi over 2 would go from 1, 0 to 0, 1. That would be pi over 2, because it's a fourth of the way all the way around the circle. And remember, the circumference is 2 pi. Halfway around is pi. And 3/4 of the way around is 3 pi over 2, because 3/4 of 2 pi is 6 pi over 4, which reduces to 3 pi over 2. And then if we go all the way around, it's 2 pi. Okay, so those are the terminal points, 0, 1, -1, 0, 0, -1, back to 1, 0. So pi over 2, pi, 3 pi over 2, and 2 pi. Got a little squish there. Now, let's find some terminal points. What is the terminal point of 3 pi? Well, let's graph it. Remember, that's counterclockwise because it's positive. So if we draw our circle here, man, that's a lousy circle, I know. I go 1, 2, 3. So I end up here, right? So that would be negative 1, 0. So my terminal point is negative 1, 0. How about negative pi? Okay, so instead of going counterclockwise, we go clockwise now because it's negative. That's negative pi right there, correct? Well, that is also negative 1, 0. So there's multiple ways to get to that point, which is pretty cool. And then negative pi over 2, obviously it's a quarter of pi. It's a quarter of 2 pi, but we're going clockwise now. So negative pi over 2 is here, so that would be 0, negative 1 would be that terminal point. So that's how we find terminal points. And here's the little checklist. There you go. So here's something to notice, that different values of t can determine the same terminal point. Now, this is the only time in mathematics where this really occurs very often. And we can actually have infinite number of t's to find that terminal point. This t can be infinite values to find this point, this point, this point, whatever point you want it to be. Okay, so how do we find something like this? The terminal point, what terminal point is determined by pi over 4? Well, that's interesting. Well, pi over 4 is halfway in between pi over 2 and 0, so pi over 4 is right here. So we know that's a 45, 45, 90, if we recall from geometry. If we don't, that's okay too. But we know that the x's and y's are going to be the same because it's a 45-degree angle. So that means that triangle is isosceles. So if we go x squared plus x squared equals 1 squared, and then we have 2x squared equals 1, x squared equals 1/2, and then we take the square root of 1 over the square root of 2, that's 1 over radical 2. Now, this is not the way we like to write it, though. We like to say radical 2 over 2. It's just cleaner. It's more exact, actually. It's because it's simplified. But also, it's easy to memorize. So it'll be radical 2 over 2. And we can see then that this point would be this. Radical 2 over 2, radical 2 over 2. So this is a 45-degree angle. So pi over 4 is radical 2 over radical 2. Interesting. And I think you'll see some things that happen as we go through here. And this is all the explanation of it, and we just did it. Radical 2 over 2, comma, radical 2 over 2. Now, let's go ahead and find all of these little missing pi over 6, pi over 4, pi over 3. What's this business? Well, remember, the circumference is 2 pi. So pretend that that's t. T equals 2 pi. But let's say t is 0. What terminal point do we have? Well, it's 0, 0. No, sorry. 1, 0. Okay, so that's that point right there. What about pi over 6? We already know pi over 4. We just determined it. Radical 2 over 2, radical 2 over 2. And I'm going to put that in here. Okay. You know this is 1, 0. I covered it up there. Let's see, what was pi over 2? Remember what pi over 2 was? It's this one right here, right? And that point was 0, 1. So we're missing pi over 6 and pi over 3. Okay, so pi over 6 is what part of 2 pi, right? Well, that's a great question. So this must be a 12 in order to get pi over 6. So it's 1/12, or it's 1/12 of the way around the circle, if I'm reading that correctly. Okay, so now it's like, okay, well, how am I supposed to find x and y? Because those are definitely not the same. Well, this is where remembering our 30, 60, 90 triangles comes in. And the pi over 6 is actually a 30. And if you recall, in a 30, 60, 90, the short leg is half the hypotenuse. So if the hypotenuse we know is 1, because that's our radius, then the short leg is a half. And then the long leg is the short leg times radical 3. Hopefully you remember that from last year. So the long leg is radical 3 over 2. So this terminal point then is radical 3 over 2 up 1/2. Now, pi over 6 is right here, or pi over 3 is right here. So now you wonder, well, how's that related to pi over 6? It's the same triangle, except now it's been flipped. This is still 1, but now the long leg is the vertical leg, or y. So this is y and x now. So that's a half, and that's a radical 3 over 2. And those are the terminal points determined by the unit circle. Now, this is a great time to take your handout and fill that stuff in right away, those points on your unit circle handout, because you will look at that for a long, long time. This would be a good place to pause, too, and make sure you understand where those points came from. Okay, we're back now. Now, finding terminal points. Now, remember, pi over 4 was radical 2 over 2, radical 2 over 2. What would negative pi over 4 be? What would this one be then? Well, we'd go right and down. So if you're thinking x is positive and y is negative, you'd be correct. So radical 2 over 2, negative radical 2 over 2. See how easy this is once you memorize these things? Okay, how about the terminal point of 3 pi over 4? What would it be? Well, I'm pretty sure, yeah, we're looking for terminal points here. I'm pretty sure that that's just nothing more than pi over 4 over here in the second quadrant. So now x is negative and y is positive, because here's your triangle, x, y. And I encourage you just to draw the x and y out. It's much simpler to see when you do that with your unit circle. Okay, how about negative 5 pi over 6? Well, pi over 6 we determined was radical 3 over 2, 1/2. So what would this one be? What would negative 5 pi over 6 be? Negative radical 3 over 2 and down 1/2. They're both negative. Very interesting. All right, now, the reference number. From these examples that we just did, we know we can find any terminal point in any quadrant we need only by knowing the corresponding terminal point in the first quadrant. Now, we use the idea of reference number to help us find terminal points. So T bar is associated with T, the shortest distance along the unit circle between the terminal point determined by T and the x-axis. All right, so let that sink in here. It's the shortest distance along the unit circle between the terminal point determined by T and the x-axis. That's the reference number, T bar. Okay, so for instance, T bar on the first one there, you can see that it's from here to here. I should use red. That's t bar. T bar here is from here to here. Shortest distance from the x-axis on the unit circle. That would be here to here, not here to here, correct? And then this would be the shortest distance on this one. Now, why is that helpful? Because it's just knowing positive and negative. If the terminal point lies in quadrant 1 or 4, okay, so let's draw this out. If it lies in quadrant 1 or 4, okay, where x is positive, t bar is going to be, we're going to move along the circle to the positive x-axis. That means we're going to go this direction. That's going to be the shortest, t bar. If it lies in quadrant 2 and 3, that's not 3, that's 4. Let's try that again. Well, really it's nothing, is it? There we go. Where x is negative, then we find t bar by moving along the circle to the negative axis, there and there. Okay, so that's how we find the reference numbers. And I'll be honest with you, I've never taught this way, so this is kind of new to me, but it also is pretty exciting. It really makes a lot of sense. So if we use this then to find the reference numbers for each value of t, remember, if we're on the left side, we're going to go left. We're on the right side, we go right. So it's pretty easy if you think about it like that. Okay, so 5 pi over 6 is right here. So since it's in quadrant 2, our shortest distance is going to be there. And I know that it's pi from here to here. That's pi, or 6 pi over 6. 5 pi over 6 minus, or 6 pi over 6 minus 5 pi over 6 is 1 pi over 6. So the reference number is pi over 6. 7 pi over 4 is pi over 4, which means it's the same number, okay? Or the same reference number is what I'm trying to say. It's just going to be whether it's x or y is positive or negative. Negative 2 pi over 3, okay, we're going to go to here. Well, we're in the third quadrant. So 3 pi over 3 to get halfway across, so that's going to be pi over 3. And we always take the positive part of it. And then the 5.8, well, remember, it's about 6.28. 2 pi is about 6.28. So that would be 0.48 would be our reference number. I'll let you digest that a little bit and think about what we just did. But that's how we find the reference numbers. And here it is again, written out in mathematical terms. I think it's better to look at the picture than it is to look at that. Okay, now, using reference numbers to find terminal points. We're going to find the reference number t bar, find the terminal point, and then figure out what A and B are, whether or not they're positive or negative. So this isn't that bad at all. So the first thing it says, find the terminal point by each given real number t. T equal 5 pi over 6. Okay, well, 5 pi over 6 is here. That means pi over 6 is there. So if you remember, pi over 6 here was radical 3 over 2, 1/2. You can look at your notes and see that. Okay, but now we're over here to the left. So now we got to figure out A and B they use. I like X and Y because that's what it is. X is negative, right? So this would be negative 3 over 2, positive 1/2. Okay, what about 7 pi over 4? Okay, 7 pi over 4 is all the way to there. Okay, so pi over 4 then is our reference number, which is radical 2 over 2 and radical 2 over 2. But we know that y is negative. So it's going to be radical 2 over 2, negative radical 2 over 2. And you could just look at the graph and know which one's positive and which one's negative. And then the final one, negative 2 pi over 3, that's this direction, right? So it gets to here. That's negative 2 pi over 3 right there. Okay, so what's left? Pi over 3. Now if you remember pi over 3, that was up here. and that was 1/2 radical 3 over 2. But in this case, they're both going to be negative, aren't they? Negative 1/2 negative radical 3 over 2. And the only way you're going to get these is to practice and memorize those triangles. Once you had the first quadrant memorized, it becomes so easy if you have it memorized. If you have this memorized right here, oops, I didn't write those in, did I? That's radical 3 over 2, 1/2. And this is 1/2 radical 3 over 2. And we'll let you use a cheat sheet for a while, but not on tests, not on quizzes. So make sure you get that memorized ASAP. Okay? All right, let's see. And I think we got the answers right here. I think we already pulled those out. Yep. Okay. So now, since the circumference of the unit circle is 2 pi, the terminal point determined by t is the same as that determined by t plus 2 pi or t minus 2 pi. So we can generally add or subtract 2 pi as many times as we want without changing the terminal point determined by t. Because of this, we can look at large values, like this one. Find the terminal point determined by t equal 29 pi over 6. Well, first of all, the first thing I'm going to do is, how many sixths are in 29? Right? How many sixths are in 29? Well, it takes 12 to get around once, correct? Because 2 pi is one time around. So that's 12 sixes. If I go around again, it's 24. How many do I have left? 5 pi over 6, right? So this is my reference point for 29 pi over 6. So then what's that point? Well, 5 pi over 6 is pi over 6. And that's negative radical 3 over 2, positive 1/2. All right, kind of cool. And there it is. There's the answer. Okay, your assignment is on WebAssign. And ask a lot of questions if you have any.